Hello, and today's purpose of the day is I can multiply special products. Let's take a look at a warm-up. This can be found on page 453 of your textbook. Special products. Why are we learning about them? Colby wants to attach a dartboard to a square piece of corkboard. If the radius of the dartboard is r plus 12, how large does the square corkboard need to be? Well, Colby knows that the diameter of the dartboard is 2 times the quantity r plus 12, or 2r plus 24. Each side of the square also measures 2r plus 24. To find how much corkboard is needed, Colby must find the area of the square, which means that you have 2r plus 24, the quantity, all squared. So let's take a look here at question number 1. What two factors equal the quantity 2r plus 24 squared when multiplied? Yeah, if you just break up the 2r plus 24, the quantity squared, you really have 2r plus 24 times the quantity 2r plus 24. So again, that squared means that I have to write out two of those terms that are in the parentheses. Question 2 says, use the FOIL method to find 2r plus 24, the quantity squared. So I'm going to take 2r plus 24 and multiply it by 2r plus 24. And when I do that, 2r times 2r is 4r squared. 2r times 24 is 48r. And then another 24 times 2r is 48r. And 24 plus 24 is 576. So if I combine my like terms, 48 and 48 give me 96r, and then plus 576. So that's what I would get when I would FOIL 2r plus 24, the quantity squared. Question 3 now says, if 2r equals a and 24 equals b, does 2r plus 24, the quantity squared, equal to a squared plus 2ab plus b squared? Well, let's go ahead and substitute in 2r for a, so what that looks like will be 2r, the quantity squared, and then in for b squared, I'm going to plug in, or for b I'm going to plug in 24. So if I have 2r squared, I distribute the 2 and I get 4r squared. And here, 24 squared is 576. So now 2 times ab would be 2 times a, which would be 2r, times b, which would be 24, and that multiplied together gives me, well, 2r times 24 is 48r, times another 2 would be 96r, so this would, equal the a squared plus 2ab plus b squared, so it would work. So this here is going to be something that we are going to use today when we are going to find the square of a sum and square of a difference. Okay, let's look at special products rule number 1, square of a sum. So we're going to look at an example with just variables, a plus b, the quantity squared, and then another example with numbers, 2x plus 7, the quantity squared. We are going to see a pattern that comes out of doing these examples that I hope you will recognize and we will talk about, and that you'll be able to start to do these problems quicker in your head and won't have to necessarily show all your work. So let's take a look at square of a sum. Let's look at the quantity a plus b squared. This is called square of a sum because I am squaring the sum of two terms. Here it's a plus b. So again, it's called square of a sum because I'm squaring two terms and then there's an addition symbol in between the terms. So what this looks like is I really have a plus b times the quantity a plus b. I have to write out right now, before I see the pattern, both binomials. I am not, and I repeat, not allowed to just distribute this 2. So don't even write this down because this is wrong. But if you were to do that, you would get a squared plus b squared, and you'll soon find out that that will not be our answer. So don't even write that down. If you did, erase it because you don't want to see that. So now if I multiply or FOIL a plus b times a plus b, I get a squared plus ab plus another ab plus b squared. If I combine my like terms, 1ab plus 1ab is 2ab. And if I had b times a and got ba, BA is the same thing as AB. They're just flip-flopped. So this would be my answer. A squared plus 2AB plus B squared. And we found that out by FOILing, or multiplying the two binomials. So now let's take a look at multiplying 2x plus 7, the quantity squared. So this here I'll write out 2x plus 7 times the quantity 2x plus 7. And when I FOIL this, I get 2x times 2x, which is 4x squared, plus 14x plus another 14x plus 49. If I combine my like terms there, I get 4x squared plus 28x plus 49. So did you see a pattern evolve between the two examples? So when I took the quantity a plus b squared, I got this answer. When I took the quantity 2x plus 7 and squared it, I got this answer. So what do you notice? You got it. We are going to take our first term and square it, hence we got 8 squared. And then we're going to take our last term and square it, and that's how we got b squared. And again, with these terms down below, 2x squared is 4x squared, and 7 squared is 49. So how do we get the middle term? That's kind of the big idea here. The middle term gives us 2 times your first term and your last term. So here on this example, it would be 2 times a times b, which gave us the 2ab. Down here at the second example, 2 times your first term, which was 2x, times the last term, which was 7, and 2 times 7 is 14, times 2x would be 28x. Now, so yes, if we take 2 and we multiply it by, again, our first term and our last term, that will give us our middle term. So the key concept written down below just states in words that the square of a plus b is the square of a plus twice the product of a and b plus the square of b. And then in symbols, there it is, and there it is in an example as well. And this was a square of a sum. Now let's take a look at the next rule, square of a difference. So here we see we have the quantity a minus b squared, and so you can see the only difference is that there's a subtraction sign, which makes this a square of a difference. So you probably can already see the pattern, or you maybe know the pattern from what we just completed on the last slide. But let's go ahead and take a look at this. So if I have a minus b, and let's see if we see the pattern evolve, but like I said, maybe you already see it. If I FOIL these two, I get a squared plus, or not plus, minus ab minus another ab plus b squared. My final answer here is a squared minus 2ab plus b squared, so slightly different than what we got on the last example. And then I'll take a look here at 3x minus 4y times the quantity 3x minus 4y, and I get 9x squared minus 12xy minus another 12xy plus 16y squared. And if I combine those like terms, I get 9x squared minus 24xy plus 16y squared for my final answer. So can you see the pattern here with square of a difference? Yeah, similar to what we saw on square of a sum, we're going to square our first term, so here we got a squared, square our last term, so negative b squared is positive b, or sorry, yeah, negative b squared is really positive b squared. And then my middle term is 2 times my first term, which is a, times my last term, which is a negative b. And 2 times a times negative b is negative 2ab. So you just got to be careful, right, that subtraction sign then will therefore make our middle term have a subtraction sign in front of it as well. Similarly, down below, when I take 3x and square that, I get 9x squared. Should move that over so it fits. So 9x squared, square our last term would be 16y squared, and then our middle term is our first term times our last term times 2, which gives us negative 24xy. So again, down below, key concept, square of a difference means the square of a minus b, and that can be filled with whatever problem you are on, is the square of a minus twice the product of a and b plus the square of b. And again, there it is in symbols and words as well, but this was square of a difference. Now let's look at the product of a sum and difference. So here I'm given the quantity of a plus b times the quantity of a minus b. So I have one binomial that has an addition symbol and one binomial that has a subtraction symbol and the same terms inside of those binomials. So here, if I FOIL this first example, a times a is a squared, a times negative b is minus ab plus ab minus b squared. What happens to my inside or middle terms? Yeah, the negative ab and the positive ab cancel out, and what I'm left with is a squared minus b squared. So by knowing that, can we figure out the bottom example without showing any work? You got it. Let's just cancel out our inside terms and make sure that we multiply together our first terms and our last terms. So I here will multiply 3x squared times 3x squared. That will give me 9x to the fourth. Then I know my middle terms will cancel out here in purple, so I don't even have to multiply those two together. But then if I go back and multiply 5 times negative 5, I'm going to get negative 25. And again, you could check your answer if you wanted to by actually going through and FOILing those two binomials or multiplying them together with whatever method. But if you know the shortcut and you know the pattern, go ahead and do those in your head. So the key concept is the product of, for example, a plus b and a minus b is the square of a minus the square of b. So again, we just squared our first term and squared our last term, but made sure we had a minus sign in between because again, one of those binomials has a subtraction sign or a minus symbol. And then here again is symbols and what we just spoke about, the product of a sum and difference. Here are 3 examples. Pause the video and try and do them in your head. Great job. I'm glad you got all 3 of them completed. Let's go through them together. So for the first example, we have a square of a difference. So this means I need to take my first term and square it, and 5x squared is 25x squared. Square my last term here, which is 4y squared, and my middle term is 2 times the first term times my last term. So 2 times 5x is 10x, and 10x times negative 2y is negative 20xy. So this would be my answer here for the first example. The second example, I have a square of a sum. So I'm going to take my first term and square it. So 7a squared is 49a squared. Square my last term and get 81. And then my middle term is 2 times my first term times my last term. So 7a times 9 is 63a, and then 63a times 2 would be 126a. So plus 126a plus 81. And then the last example, here's the final one, product of a sum and difference. So here I'm going to square the first term, use a different color, which would give me 4x squared, and square my last term. Make sure I have a minus sign in between. And I don't even have to worry about my middle terms because those will cancel out and cross out because, again, I have 1 minus and 1 plus. Thanks for listening. Have a great day. Bye-bye.